this problem, we need to draw shear moment diagram for this beam by using the function method, which means we have to write down what is the shear moment function so that we can draw the shear moment diagram based on the function. So you can see the reaction force is given. So the first question is how many shear moment function we are going to have. So this is how. Try to use your card or use your calculator to help you to see. So see, if we do the cut here, we can only see one beam with one force. However, if we will keep moving our cut, once we pass the B location, you can see more loads are involved, which means our FBD was changed. So in this way, we can see we are going to have different shear moment function in this region than in that region. So if we keep moving our cut, you can see the uniformly distributed load will be involved, which means we are going to have another moment shear function here. And this is how. Whenever you had your FBD change, you are going to have different shear moment function. So you might say, when I cut it here or cut it here, will that be the same function? The answer is yes. You can see overall the load doesn't change except the length getting a little bit longer, then which means you are going to have a little bit more distributed load. However, we can represent that by using the length. Okay, so as we explained, we are going to do 3 cuts and we are going to have 3 different shear moment function. So let's do the cuts. So whenever you do the cut, the next thing is trying to pick which side you want to use as your FBD. So for example, for the 1-1 cut, would you like to pick the left side as your FBD, or you want to pick that side as your FBD? As you can see, if we choose right hand side, we are going to include a lot of loads. So why not just use this side as your FBD? So now let's read. At the 1-1 cut, we are going to pick left hand side as our FBD. So you can see we had a reaction force. Anything else? So if there's no external force, then the next thing is trying to draw the internal force. We can see we are going to have shear force because it's cut at a known distance between A and B, so we are going to use X to represent that the shear function is going to change with your cutting location. And then we are going to have a bending moment. And always remember, we are going to draw the internal force in the positive direction for now. So you can see we include all the forces. For this problem, since there's no horizontal force, so I'm not going to draw the normal force. So after we include all the forces, the next thing we had to show is the geometry. Always remember, from the start to your cutting location, this distance is going to be called cutting location X. Okay, so now let's take a look. If we were trying to summarize the force in the Y direction, we can see negative. So the shear function is going to be equals to the 3,600 pounds. And always remember, the cutting location here cannot exceed the 5 feet, because after passing the 5 feet, we are going to involve different load. So which means for the 1-1 cut, your X is going to be valid from 0 distance to the 5 feet. Now we have to write down the moment function. So always remember, let's try to summarize moment at the cutting location here. Because if you made some mistake on the shear function, you can still get the correct moment function. Let's see. We can find the moment function will be 3600 multiply x. So we done the first cut, which means we can move to the second cut. Again, which side you want to pick as your FBD? This side or another side? So normally if we can avoid uniformly distributed load, let's avoid that. So let's try to draw the 2-2 cut. So let's take a look. The 2-2 cut will be after B point, but before C point, which means the valid zone for the cutting location 2 will be 5 feet to 10 feet. And let's try to redraw the FBD. Okay, so for the shear moment function here at the cutting location, that's going to be your shear. This will be your moment. And let's mark the dimension. So you can see from A to B, this will be 5 feet. And always remember, from the origin to the cutting location, this will be x distance. So which means, what is the distance from B to the cutting location? You can see from the geometry that's equals to x minus 5. So with everything ready, again, let's try to summarize the force. In the y direction, then we had 36 go up, we had 3,000 going down. And the moment is not going to affect our shear function. So which means we can obtain the shear function is going to be 600 pounds. Let's summarize the moment at cutting location so that we can obtain the moment function. If we combine every terms here, we should be able to get the moment function from 5 feet to 10 feet will be so now we had the last cut we have to draw. So again, we use paper or the card to help us make a decision. So what's this? Are you going to pick a left-hand side or the right-hand side as your FBD? As you can see, the easier side is going to be right-hand side. So I highly recommend you to replicate whatever your eye can see. So we had a reaction force, and we also see the uniformly distributed load. The magnitude is going to be 500 pounds here. So now what you have to do is always remember, try to draw the shear and moment function in the positive direction. And the next thing you have to do is mark the dimension. What is the distance we should put it here? Are we going to put x? So let's go back to here, to the original picture here. Always remember from the origin to the cutting location. This is going to be called x. So which means from the geometry here, what is the length? We should put it on our FBD. So that's going to be the whole length of the beam minus the cutting location. 20 minus x. So now we do the same thing. Try to obtain the shear moment function by the equilibrium equation. So we have to be very careful here for the uniformly distributed load. So remember, 500 multiplied 20 minus x here is only represent the force. We have to find out the distance. So that's going to be half of the cutting length. And by the way, what is a valid range for the 3-3 cut? It will be